From the previous lecture, we know that what is a matrix, how to create a matrix, and how to use the Numpy. In this video, we will see that some other functions or other operations that we can do with a matrix. So for that, first let me import the function. So import Numpy as NP I can write. So instead of NP, you can write anything else also. So first, what we have done, we have just imported. Then let us just create two matrices. So let us just create matrix. So how to create? Let me take one variable, that is matrix. So let me just take A. Okay, for simplicity, let me take the variable A. I want to create a matrix. So what I have to write? NP dot array. Okay, so this is the function to create a matrix inside a parenthesis. So every row will be inside a square bracket. So here I'll write, let's say 1 comma 2, one row, then give one more comma, and inside that another, give another square bracket, and then you write like 5 comma 10, let's say. Okay, 5 comma 10 will writing. So this is what I have created, the matrix A. Let me create the matrix B as well. So here also np dot array, and then parenthesis, then square bracket. Let me write 5 comma 6, then here one more comma, one more parenthesis here, and here we will be writing, let's say 3 comma 4. Okay, so what I have done here is I have just created two matrices here. So let us run that. First the error. Actually, there should not be an error. Why the error is coming? Let me just take. Okay, I missed one more square bracket here. It should be, yeah, the whole matrix should be in a square bracket, and then each row will be in a square bracket. Fine. Now if I print A, then I'll give one comma, then I'll give a quote. Here I'll write slash n. That's because I want to print that in the another row. Then I'll write B. So let me write some other message also here. The matrix A is. So now what it will do? It will print a message. Then it will print matrix A is, and here also we'll do the same thing. The matrix B is, and then close it, comma. So it is going to print the two matrix for me. So matrix A is 1 2 and 5 10, and the matrix B is 5 6 and 3 4, that we have entered here. So that is what it is printing here. So now let us try to do some operations with matrix. Let us do the multiplication. Okay, so there are two types of multiplication in matrix. So one is bit by bit multiplication, and then the other one is dot product, or means dot multiplication, we say that. Fine. So multiplication, so this bit wise, or we can write that as element wise multiplication. Okay, fine. So how to do that? It's very simple. So let me write the result multiplication is equals to, so multiplication will be equals to just A into B, that's it. So that will be your answer. So what we are going to do here is we are going to print that also. So print, in message I will write the multiplication is, comma, here I will write the answer, multiplication. Fine. So see, it is printing. How it is printing, let us see that. Let me write the slash n here so that it will print in the new line. Okay, now let us understand here. So what it is doing, it is multiplying 1 into 5 and the value is here. So the second element 2 is here and the second element 6 is here. So 2 into 6 is 12. So it is writing 12 here. Then 5 into 3 15, then 10 into 4, that is 40. So this is how it is doing multiplication element wise, one element by one element the multiplication is happening. So next type of multiplication is there, we say that as a dot product. So this is the actual way the matrix multiplication should happen. you might have done in your earlier days matrix multiplication a1 b1 plus a2 b2 plus a3 b3, like this it goes on. So this is how the matrix multiplication will be doing. So for that let me write dot multiplication. So dot multiplication equals to, so here what I have to write, in this case we cannot do the direct operations, in this case we have to write np dot dot. So I have to use a function there, and then in the bracket we have to write the what are the matrix a comma b. Fine. So this will print the dot multiplication of the matrix, which is the actual way, a1 into b1 plus a2 into b2, like this goes on. So here again we will print. So let me copy the print from the previous one. We'll just change the variable name here. So the dot multiplication in this case is, so this is the dot multiplication variable. So I'll just copy this and I will paste it here. Okay, now see these two results are different. So here also multiplication is happening, here also multiplication is happening. But if you calculate, it is the dot product, that is a1 b1 plus a2 b2 plus a3 b3, and it goes on like that. Fine. So next type of operation we can do with matrix is just find a transpose of the matrix. Okay. So here we will find the transpose of the matrix. Okay, so it's very simple how to do that, find the transpose of a matrix. So here let me write transpose as a variable. So transpose equals to, here also we have to use the function np dot transpose. Okay, so this np, why I am writing np again and again, so see here I have imported numpy as np here. So instead of importing np, you can import as a b c d whatever you want, and you can use that np. Instead of writing np for np dot transpose, you can write a dot transpose also, but generally np is taken, that's because nomenclature stands for the np, that means numpy. Fine. So np transpose, in bracket just write which variable you want to transpose, then we'll print that. What we are going to print? So print the transpose is, then comma we'll write the variable, that is transpose, where transpose variable waiting here. So see, it has calculated the transpose of the matrix A. So if you can see, so let me print the matrix A here also, print A, so that we can compare that. Fine. So that's why I'm just printing the value here, it's not required actually. So see, the matrix initially was 1 2 5 0, so it has transposed it to 1 5 2 0. So you can see the rows and columns are transposed. Okay. So next what you can do with a matrix is we can find the we can find the inverse of a matrix. So how to find the inverse? So the inverse can be found in the simple way also. So inverse of the matrix. So how to find that? For that also, let me write inverse here, inverse as a variable, and this I will just write np dot linear algebra, np dot linear algebra dot, what I want to do, inv. Okay, and in bracket I will just write, let me take this time b, and then we will print the inverse of matrix b is inverse. The y inverse, I am just calculating the variable here. So now this will give the inverse of the matrix. So easily it can calculate the inverse of the matrix here also. So next it comes to find how to find the determinant of a matrix. Okay. So determinant of a matrix also similar procedure. One command is there. Okay. So how to find the determinant of a matrix? Let me write det as determinant. So that is equals to. So for determinant, what we have to do here is same np dot linear algebra, what I have used there. So I have to write in line a, okay, linear algebra, and in then bracket you just write for which variable you want to find the determinant. Okay, then you can just write a print statement there to print that also. So let me just write determinant here. Okay, here the spelling mistake was there. Again, what error it is showing? Module object is not callable. Why? NP dot linear algebra. Okay, sorry. Dot det. We are finding the determinant here. Okay, so find this will give me the determinant. So lastly, one more operation we can do, that is calculating the eigenvalues. Eigenvalues of the matrix. So how to do that? Let me take eig here as a variable, that is equals to np dot linear a alg linear algorithm dot what we are going to do, we are going to find the eigenmatrix. So eig stands for that, and then just write for whichever matrix you want to find the eigenvalues. So we'll just print this value of a. So it is the eigenvalue of the matrix a. So we can calculate for that matrix b as well. So this is the eigenvalue of the matrix b. Okay, so this is how we can calculate the values of eigenvalues. Now once the eigenvalue is calculated, you can see it's not showing anything. Means how do you know? So basically when eigenvalue is calculated, after a will print eigenvalue is calculated, it creates two other new things. One is called as eigenvalues and one is called as eigenvector. So that will print here. So print, here I'll take eigenvalues comma eigenvector. So as I said, it will create two values here. So that's why I'm taking two variables here, and will print each variable. So one is eigenvalues comma eigenvector. Okay, so the print statement. Okay, let me give a line here so that we can differentiate that. Now 8.77, this value is the eigen value for me, and this is the eigenvector for me. So to simplify that, we can print one more statement in between, the eigen values and the eigenvectors. Okay, so these are the eigenvalues and the eigenvectors that can be calculated from a Numpy library. In the next video, we will see that how you can solve a linear algebra with two variable or three variable system. So that will be interesting. So do like that, watch video also.